Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are solving this paper that is of the year 2025. It's the February-March paper. There is only one variant, that is variant 52. So let's get started with the paper. The first question. It says Jacob throws 3 coins at the same time. The first coin is biased, the second one and the third one. All the 3 coins are biased. The probability of obtaining a head is 1/3, 1/4, 1/5 respectively. The random variable x is the number of heads obtained. Show that probability x is equals to 2 is this much. Draw up the probability distribution table, and given that expectation of x is this, find the variance of x. Now this is a traditional question that comes, and it's about the concept that you can have 3 heads, you can have 3 tails, you can have 2 heads and a tail, you can have 2 tails and a head. So there are 8 possibilities. So let me just write the groundwork for this one. So for 3 heads, there is one option. And similarly for 3 tails, there is again one option. And then for head, head and tail, there are 3 options. Why? Because this is 3 factorial divided by 2 factorial. For the 2h, that becomes 3. Similarly, tail, tail, head, according to the same principle, there are 3 options. So 1, 1, 3, 3, that adds up to 8. Therefore, 3 options are there for the heads and tails and all these things, and all the possible combos are 8. Now, let's get started with this. Over here, I have written coin 1, coin 2, coin 3. So there are 3 coins over here. That is coin 1, and then there is coin 2, and then there is coin 3. And the corresponding probabilities of getting a head is this thing. So this is 1/3 for head and 1/4 for head on coin 2, and similarly 1/5 for head on coin 3. And there is this thing, the head, that's right over here, and tail is obtained from subtraction. Now when we talk about number of heads obtained, so I have a habit of doing everything together. So first of all, let me jot down all the possibilities. So jot down all possibilities. Jot down all probabilities associated with the possibilities. When I use the word possibilities, I mean the outcomes. All possibilities and corresponding probabilities. So that is what the chapter is all about. So now when we have x is equals to 0 and we are talking about 3 tails, so that is this probability into this, that is a straightforward answer. Do not reduce the fraction. So again, a very, very important thing, do not reduce the fractions. It makes life very, very easy for a lot of purposes. The next one. Now this thing is done. Go to the other extreme. That is probability x is equals to 3. That is 3 heads. That is 1/3 and 1/4 and 1/5. That is 1/60. So that is 1/3, 1/4, 1/5. That is 1/60. So now this thing is done. Now you can find out one of these that the examiner asks, and can find the other one by subtraction also. So which one is the examiner asking? The examiner is asking for x is equals to 2, where x is the number of heads. So the examiner is asking for 2 heads. That is tail, head, 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 tail, head, 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 tail. So there are 3 options, and all these 3 are taken care of. So now when it's about tail, head, head, so tail from here, and then head and head from here. So therefore this is 2/3, 1/4, 1/5. This is 2/3, 1/4, 1/5. And what I have done is that I have multiplied the 5 and the 3 and the 4 and the 5, and I have written it collectively as 60. So this is for tail, head, head. So let me write over here. This is tail, and this is head, and this is head. The next one is head, tail, head, head, tail, head. So when we talk about head, tail, head, let me remove these tick marks so that we can think clearly. So head, tail, head. This is head, this is tail, this is head. Focus on the numerator. That's 1 into 3 into 1. That is 1 into 3 into 1. The denominator is already taken care of. And what is the last one? The last one is head, head, tail. So the last one is head, head, tail, numerator 1 into 1 into 4. Therefore, that is 1 into 1 into 4. That is head, head, tail. So therefore, this comes out to be 9 over 60. Now, since the examiner has reduced it, therefore, for this part, I'm fulfilling the examiner's wish of reduction and I'm giving the answer over here. And again, how is this one obtained? So this is tail, tail, head. This is tail, head, tail. This is head, tail, tail. So that is obtained this way. And of course, I could have obtained this by subtraction because this was 24. This was 9. This was 1. So 24 plus 10, 34. Therefore, this denominator, this numerator has to be 26. And then look at over here. So that's a probability distribution table. For 0 was the easiest, 3 was the easiest, 2 was the one that was asked in part A. And this can comfortably be solved by subtraction. So that is how this table is created. Expectation of x was given over here. That was given in this particular question. They could have also asked for it, but maybe they're running short of marks. So now this thing happens. An expectation of x square, that is sigma p x square. So take the value of x, square it, multiply with the numerator. Value of x, square it, multiply with the numerator. And that is one of the good reason of keeping the denominator intact, of not reducing it, so that I can comfortably divide by 60 at the very end. Leave the answer in fractions. Apply the rule for variance. Let me just pull this up. I think that would cause a trouble. So now it's over here. So therefore, variance of x is calculated this way. And you get this answer. That is expectation of x squared minus square of expectation of x. I don't know. This always causes trouble to me. So therefore, that is how you get the answer. You can leave the answer in the exact form. You can convert it into decimals, but take care of the accuracy. So now the first question is done. Question number 2. Now it says last year, an online store sold a large number of computers. 55% were made by company F. So red one is F, blue one is G, and the green one is H. A random sample of 3 customers who each bought a computer from the store is chosen. Find the probability 3 customers bought computers all made by different companies. Second part, a random sample of 12 customers who each bought a computer from the store is chosen. Find the probability fewer than 10, lesser than 10, that means lesser than or equal to 9, of these customers bought a computer made by company F. This is binomial. So I'm first figuring out what each part represent. And then further on with binomial, a random sample of 150 customers. This is suitable approximation, and the probability of success is the probability of buying computer H. So now I have written it all over here. F is 55%, G is 30%, H is 15%. All 3 are made by different companies. So when they are made by different companies, that is probability of F into probability of G into probability of H. Multiply it with 3 factorial. Why are we multiplying with 3 factorial? Because there are 6 ways of arranging it. So what are the 6 ways of arranging it? FGH, FHG, and GFH, GHF, and HFG, HGF. There are 6 ways of arranging it. So that is the answer for this part. If it's exact, leave the answer as it is. Second part, it's about binomial, and the probability of success over here is of company F. So that is the probability of success. That's the number of trials, less than n, less than or equal to 9. That is too much to calculate. That is probability F is greater than or equal to 10. Now I have deliberately left these ones blank so that I can fill it up for you. So now probability of success is 0.55. So you write 0.55, 0.55, 0.55, and the powers of 0.55 is 10, 11, and 12. And the remainder probability, that's a combination of these two, that is 0.45, that has the remainder power, which is 2 over here, 1 over here, 0 over here. And now this is writing for this, writing for this, writing for this, and then adding it up and then giving the answer correct to 3 significant figures. So all this effort that you are doing at this stage, make sure it's not lost because you just forgot to take care of accuracy or things like that. Keep that in mind. Now part C, that is about H. So part C is about H, and this is the probability of success of H. Number of trials is 140. NPQ, NP, NQ, NPQ, always justify. What is the justification? That is, since NP is greater than 5 and NQ is greater than 5, therefore it follows X or H, whatever you want to write it, follows a normal distribution. This is the mean. So this is the mean and this is the variance. NPQ is the variance. NQ is just used for justification. It has no name as such. Then probability X is greater than 24. So now when we are talking about greater than 24, that means this is normal approximation. So we have to do continuity correction. So this is 24.5. This is 23.5. Two possible scenarios are there. There is this blue one and then there is this green one. Since it's only greater, so therefore choose the one that is not including 24. So that is this blue one. So therefore the correct option is the blue one, which is 24.5. So 24.5 is the correct continuity correction. And then it's back to the basics. You standardize, you get the z value, z greater than something is 1 minus probability z lesser than something, subtract, and then you get the answer. So that is how question number 2 is done. Now question number 3. This is cumulative frequency. The length of 250 leaves of a certain plant are measured. The results are summarized. These are the class intervals because it's ending at 9, starting with 10, ending at 14, starting with 15, and so on. And one thing that people need to understand is that when we talk about cumulative frequency, class width does not make a difference. Class width is no issue. We have to work with upper class boundary. We are working on the concept of less than. So that is cumulative frequency. If we are working in mid value, and that is used for what? That is used for mean and standard deviation. Remember, the mid value is half lower class interval plus upper class interval. X is also equals to half lower class boundary plus upper class boundary. And I think I put a next bracket, extra bracket over here, lower class boundary plus upper class boundary. When we talk about histogram, yes, class intervals should be converted to class boundaries if that is not already the case. And that is the concept of lower bound, upper bound of O-level math. So that is the concept of inequality. If the difference is 1 unit, we add and subtract 0.5. If the difference is 0.1 unit, you add and subtract 0.05. That is the same thing. That is the basic thing that we need to take care of. And class width is necessary because it usually involves frequency density. That is upper class boundary minus lower class boundary. Yes, you can also obtain it from the interval, but that's no use because you have to add 1. And for histogram, class width, class boundaries is a must. So class boundaries is a must for histogram, and it's also a must for cumulative frequency curve or diagram. Got the idea? So that was a brief analysis on the sidelines. So now over here, you convert it into boundaries, 4.5 to 9.5, 9.5 to this thing, and so on. And then take the upper class boundary. Lesser than 9.5 is 18. Lesser than 14.5 is 28 plus 18. So basically we are going in this direction. 18 plus 28 is 46. 46 plus 60 is 106. 106 plus 72, 178. 172 plus 48, 226. 226 plus 24, 250. This last one should correspond with this. And there is one other thing that I need to take care of. Let me just draw it on the sidelines. That is over here, which is the lower class boundary over here. This is 4.5, this is 9.5. So choose this 4.5, write it over here, and the corresponding cumulative frequency is 0. This is the point on the x-axis. So that thing is very, very necessary. That is where the graph is touching the x-axis. Secondly, I did not draw the axes because the paper is kind of, somebody made a very bad scanning of it, but at least we got the paper, so it won't be a straight line like this. So that is why it is kind of tilted a little bit out and it's going like this. So that's how the graph is drawn. The vertical axis is never compressed, keep in mind. So vertical axis can never be compressed. A lot of people ask all these questions at the last moment. So here are the answers. And the horizontal axis, yes, it can be compressed. And even though the space was very less, I still did the compression. So 0 till 4.5, I drew this thing, the jacket line, the squiggly wiggly, and I started with this dark line. Think about this. I started with this dark line as 4.5. A lot of people, they label this thing as 5 and then they go 1 unit back. That is waste of time. 4.5, 9.5, 14.5, all the way till 39.5. The points are plotted. Let me make them more obvious over here. So this is a point, this is a point, and then this was a point. This one, and this one. I think there were 6 points. 1, 2, 3, 4, 5, 6. Besides this one, that is this one over here. So 7 points, you join it, you get the answer. And then it says 38% of the leaves are of length k or more. For cumulative frequency, it is less, that you translate it to lesser than. That means 100 minus 38 is 62%. 62% of cumulative frequency, if I read the value from the x-axis, because cumulative frequency is on the y-axis. So from y-axis to x-axis, 62% of cumulative frequency, that is 250, correct? Yes, it's 250. That is 155. I go to 155. I read of this value. That is right over here. So this is answer of part B, and that is how you obtain it. And this answer comes out to be 22.5. And then it says calculate an estimate of the mean length. Now, giving you some extra knowledge, which I think the examiner has not asked it as yet. Why is this an estimate? Because when we draw a frequency distribution table, we assume that the data is evenly distributed in a class interval, which may or may not be the case. Now, let me explain this thing in simple English. So now over here, there was a class interval or class boundary, doesn't make a difference. Over here, we have this thing, 5 to 9, and there are 18 pieces of information. Now, we don't know whether they are evenly distributed. Let's say 5, 5, 5, 3 5s, 3 6, and 3 7s, and 3 8s, and 3 9s. And since it's 18, maybe 1 more 5, 1 more 6, something like that. We don't know whether it's evenly distributed or not. But the calculation is based upon the mid value. 5 and 9 is 14. 7.5, the calculation is based on that. 7. So now, when we do the calculation, we assume the data to be evenly distributed, which may or may not be the case. That is why it's an estimate. And if we were calculating the mean from raw data or the mean from ungrouped frequency distribution. What is ungrouped frequency distribution? Single value of x, single value of f. That is just the original data written out neatly. So this will be exact. There is no issue with this. The issue lies with this thing in which a class interval, class boundary is given. This is called grouped frequency distribution. The mean and standard deviation that you obtain from here, that won't be exact, that will be an estimate, and that is the reasoning for this. So now over here, I have used the mid value x, that is 7, 12, 17, 22, 27, 34.5. And over here, you multiply it with the corresponding frequencies and add it up. This is frequency distribution. That is the working. That is the answer. And I think the answer, unless they say, no, they have not specified anything. So I should write x bar as 20.8, correct to 3 significant figures. Check out for any calculation or something like that. Question number 4, a nice question. It says Eddie has 16 toy cars, of which 8 are white, 5 are black, 3 are silver. So I cannot use the color white. Black would be too mainstream, and silver not possible to use. So therefore, white, black, silver, these are the colors that I have associated with it. They are selected at random without replacement. Find the probability all 3 cars are of the same color. So now in this particular paper, what I'm observing, let me share my observation with you. That observation is that they have focused a lot. So they have focused a lot on this arrangement thing. Like triple A, it can be arranged in one way, and ABC, it can be arranged in 6 ways, 3 factorial. And if we have something like AB, it can be arranged in 3 ways, because that's 3 factorial divided by 2 factorial for the A's. This is 3 factorial, this is 3 factorial over 3 factorial. How do I know this? Because first of all, I've solved the whole paper. That was very obvious. And the second thing over here, they have used this concept over here. That's the first instance where they have used it. They have, that's the same question, my bad. And then they have used it. I think this is the second one, second type that they're using it. Again on this thing. And there is one other place where they are using this thing. I think these are the 2 places. And of course, this permutation combination is there. That is for sure. But this is more than usual that they are using it. So now, which question are we on? We are on question number 4. Now it says, find the probability all 3 cars are of the same color. So it could be white, white, white. Now there are 2 ways of doing it. One of the way is using probability concept. 16 becomes 15, 15 becomes 14. There are 8 white, so 8, 7, 6. There is no multiplication because there is only one way of arranging it. I'm leaving the answer in the exact form. I multiplied these 3 separately. Dot means multiplication. Brackets together means multiplication. I multiplied these 3 separately. 3 blues, that is 5, 4, 3. 3 silver, 3, 2, 1. So 336, 66 added up. You get this thing, reduce. I won't prefer this thing, but if someone does it, and if he or she takes care of the accuracy, that is perfect. But I love the exact form, and the examiner loves it too. Method 2. Method 2 is using the concept of combination. 16C3 is without any restriction. So without any restriction, that is 16C3, that comes out to be 560. So the denominator is 560 all along. That is 560, 560, 560. Over here, we were multiplying these 3, that was 3360, 3360, 3360. Over here, we are using the concept of 16C3, that goes down. All 3 are white. So only white is considered, 8C3. All 3 are blue, 5C3. All 3 are silver, 3C3. 56, 31. Now this one is already the answer in the reduced form. That is 67 over 560. This came out to be this, reduced to this thing. So both methods are perfectly possible. A very, very nice question. Again, using the concept of this. So this concept was used. Now let's see where are they using this. It was partially used in that head and tail question. So now over here, find the probability that when cars are selected, at least one car is white and at least one car is black. We are selecting 3 cars. So it could be one white, one black, one silver. So white, white, silver, that's one option. It could be 2 white and 1 blue, no silver. It could be 1 white and 2 blue, no silver. Got it? So let me read it again. White, blue, silver, one of each, because that's at least one is white and at least one is black. So this is not blue. I mean, I'm just telling it as blue because it looks blue. It is blue, but officially this is black. So this is 1, 1, 1. This is 2, 1. This is 0. This is 1, 2. This is 0. Just apply the combination thing. 8C1 is for this. 5C1 is for this. 3C1 is for this. That's 120. Similarly 140. Similarly 80. That's 340. 340 over without any restriction. That is 560 right over here. So now then you get this answer. Method 2, using the concept of probability. Over here, when we say probability, is basically probability and permutation. Over here, when I say probability concept, this is probability and permutation. Because all these 3 are the same, there is only one way of arranging it. So all 3 colors the same, W, 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 that is one way, or B, 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 that is one way, or S, 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 that is one way. That is why you don't see the permutation over here, but over here you are going to see it. So now one of each. This is like 3 different letters. It can be arranged in 3 factorial ways. WWB, that is 3 ways because this is 3 factorial divided by 2 factorial for the W's. This is the same WBB, that is 3 ways. So multiply out the numerators, multiply out the numerators, multiply out the numerators. The denominator was the same previous one, that is 3360, 3360 and so on. And that is the answer for total probability. So that is how you achieve this thing. That is 17 over 28. So that is the answer over here. And the answer over here is also 17 over 28. A very nice question. A very nice question about probability, but using either the probability and permutation or combination. So this thing is done. Conceptual question. Let me write one more thing over here. Expect something like mutually exclusive and independent, and maybe a table type question in your upcoming May, June 2025, one of the variants. So expect something like this tomorrow. So that is one of the things that I feel should be there. Now, what else is there? Just a basic question, nothing special. The mass of peaches sold per day in a supermarket is normally distributed. That's the mean, that's the standard deviation. So let me highlight, that's the mean, that is the standard deviation that goes over here. And always write down the distribution first. Find the probability. Mass of peaches sold on any given day is between 56 and 75. So X lies between 56 and 75. Standardize, you get a negative value, you get a positive value. And this is rule number 7. So this is rule number 7, that Z lies between a negative value and a positive value. Phi of the first value plus phi of the other value. We always discard the negative sign. This is the probability. This is the probability from the table. Of course, you have to go to the table and then add, subtract 1. This is the answer, correct to 3 significant figures. Of course, this cannot be fractions. It has to be decimals. Second part. The mass of cherries. So that was, I think, peaches. And now it's about cherries. So the mass of cherries follows a normal distribution. This is the mean. So let me highlight it. That's the mean. The standard deviation is sigma. It is known that 10% of the days less than 59.1 kg of cherries are sold. So now, first of all, write down the distribution. The variable y is used. And this is the statement over here. This statement is this. Y lesser than 59.1 is 10%. Now, this is a question of back solving. When it's a question of back solving, the very first thing is that at least 50% probability should be there. At least 0.5 probability should be there. So this is 10%. What do? we subtract the probability from 1 and flip the inequality. So this is a must. Without it, do not even proceed. That's the way I have taught it. Maybe someone could have taught it in a different way. The way that I have taught it, the 2 rules for batch solving, listen to it. Make sure the probability is at least 50%. If not, subtract the probability from 1 and flip the inequality. Now, if z has a greater sign, z value is negative. If z has a lesser sign, z value is positive. That's a simple rule. So now we standardize this thing. We go to 90% over here. Go to 90% probability. The z value from that strip down there is z is 1.282. The negative sign, you apply it on the basis of this. And then standardize. Standardization is done. Equate and solve, and sigma comes out to be 10.4, correct to 3 significant figures. So now this thing is also done. Now the next 2 parts. The supermarket is open 7 days a week. Now why have they written it? A lot of people can confuse this thing that this is not the number of trials. So this is not the number of trials, because you will soon see that the question is about geometric. So in geometric, there is no number of trials. There is no n over here. Why they are saying? Because you should not stop on any particular day. You might think that this is a holiday or something like that. There is no holiday. It's open 7 days a week. Part C and part D. Let's look at this. It says, find the probability in a randomly chosen week. Find the probability, hold for a second. Find the probability in a randomly chosen week. The first day on which less than 59.1 kg of cherries are sold is the 5th day. So now this 7 days, or maybe the whole month, it's open every single day. What difference does it make? This is what? This is geometric, and the probability of success is 0.1. How do you get 0.1? This 59.1 over here, there it is. 10% of the days less than 59.1 kg are sold. So less than 59.1 kg, therefore the probability of success is 10%. That is the probability of success. So first 4 days are failure, the last one is success, nothing to do with the 7. Except there is no stopping, and whatever is happening during this day. So this is 0.0656. That is the answer for this particular part. Now the next one, what does it say? Now it says find the probability in a randomly chosen week. The first day on which less than 59.1 kg of cherries are sold is before the 5th day. Again, it's the same thing. That is, x follows a geometric distribution with 0.1, less than 5, before the 5th day. Less than or equal to 4. So we have this formula, probability x is less than or equal to n. It's 1 minus q raised to power of n. So if p is 0.1, therefore q is 0.9. We are using this q over here, power is 4, and you get this answer. Question number 6, and I think that is the last question. A very, very nice question. It says Alicia or Eliza has 10 different books from the series Squares and Circles. It has nothing to do with squares and circles. That is the name of the series. The books look similar except for the color. In other words, the books are different. The books look similar except for the color. There are 3 blue books, 2 red books, 2 yellow books, 1 orange book, 1 purple book, 1 green book. Alyssa places the book in a row on her shelf. She's interested in the arrangement of colors. Now when she is interested in arrangement of colors, now for this purpose, they are identical. Different type, same color. So now over here, since they are interested in arrangement of colors, therefore the colors are identical, you have to take care of them. How many different color arrangements? They are asking this deliberately. How many different color arrangements are there of the 10 books? So look over here. There are 3 blue, 2 red, 2 yellow, 1 orange, 1 purple, 1 green, 10 factorial divided by 3 factorial for the blues. So let me write over here 3 factorial for the blues, 2 factorial for the reds, 2 factorial for the yellow. Make examiner your friend. Till the examiner everything that you are thinking, jot it down on paper. So jot it down on paper all your thinking process to the best of your ability. Do that. And that will lead to show all essential working, because unless and until you don't show your essential working, then getting your A would be difficult. The next one, how many different color arrangements? Again, it's asking for color arrangements. How many different color arrangements are there? Let me just use this color. Color arrangements are there if of the 10 books in which the 3 blue books are together, but the 2 yellow books are not next to each other. So I have done this question in 2 different ways. Again, it's on the basis of color. So this first one that you're seeing, what I have done is that, actually this should be step 1. So the 3 blue books are the same. So 3 blue are together. Not same, they are together. And this is 3 blue are together and 2 yellow are together. So now look at the working. What have I done? Over here, when 3 blues are together, 1, 2, 3, 4, 5, 6, 7 plus this box, that is 8 factorial, divided by 2 factorial for the yellows. So therefore, this is 2 factorial. Let me choose the black color. This is for the yellow and 2 factorial for the reds. This is happening inside the box. So this is happening inside the box. That is 3 factorial over 3 factorial, 3 factorial over 3 factorial, which is 1. So this is the answer that you get. Now, what is this one? This is 3 blues together, 2 yellows together. So we are doing something that the examiner has not asked for. So first of all, let me choose this thing. This 3 factorial over 3 factorial, that is this thing blue. This 2 factorial over 2 factorial, that is this yellowish kind of thing. And what else is there? 1, 2, 3, 4, 5, 6, 7, that is 7 factorial divided by 2 factorial for the reds. So this 2 factorial is for the reds. This 3 factorial is for the 3 blues. And this is for the 2 yellows. That is how this thing is done. So now we are looking for the difference, because we are looking for the 3 blue books are together, but the 2 yellow books are not next to each other. So this is the concept of mutually exclusive. That means without any restriction of this type, without any restriction, minus together, the 2 yellows are together, will give you the 2 yellows not together, but the blues are together. Blues together only. Blues together, yellow together. The difference is blues together, yellow not together. That is the concept that's used over here. Very, very nice question. So now over here, method number 2, the space method. The 3 blues in a box. There are 1, 2, 3, 4, 5, 6, 7 spaces. Why there are 7 spaces? Because 1, 2, 3, 4, 5 and 6. There are 6 objects. The box is considered a single object. And we want to rearrange. We want to make sure that the 2 yellows are in these blanks. So 7p2 over 2 factorial. This is for the 2 yellows. 6 factorial over 2 factorial. This is for the 2 reds. 3 factorial over 3 factorial. This is for the 3 blues over here. So this is the 3 blues over here. That is done like this. Got it? So of course this is direct answer. That answer is based upon subtraction. Both methods are equally beautiful. Now let's look at this one. How many different arrangements are there of the 10 books with exactly 4 books between the 2 yellow books? Now remember that question that was there in October, November 2024 variant 53. There was this permutation combination question. Do go ahead and watch the video. It is a very, very important question. I try to do it in a very simple way, alhamdulillah, and that is what I'm successful at. That was a difficult question. This is the relatively easy version. How many different color arrangements are there of the 10 books with exactly 4 books between the 2 yellow books? So there is yellow, there are 4 between this and 4 separate. Now that is the only thing. This is like one of the questions that we did in class, Mary and Francis and all these things. So now keep on shifting. So this is first position and this is sixth position. 1, 2, 3, 4, 5, 6. 1 and 6. This is 2 and 7. This is 3 and 8. This is 4 and 9. This is 5 and 10. So that is why you are having 5 lines over here. You can draw a diagram. You can think about the positions yourself. So 5 lines for the 5 possibilities. And for these, there are 8 factorial, as simple as that. Naturally, there are 2 blues. There are 3 blues and 2 reds. So there are 3 blues and 2 reds. So this is blue, 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 and this is red, red. And this is the answer in the exact form. So in permutation combination, leave the answer in the exact form. There is no rounding off. So now let's look at the last part. It says, Alyssa select 4 books from her 10 different books. They are different books from the series Squares and Circles. Find the number of different selections if the 4 books include at least one red book, at most 1 blue book, exactly 1 yellow book. So this is just like the questions that we have for 3 different kinds of flowers, or the mountain bikes, the hiking bike, or something like that. So all those kind of things. So this is a question like that, and it specifically says different. This is not identical. Find the number of different selections if the 4 book contains at least 1 red, at most 1 blue, exactly 1 yellow. So now this is how I have broken this up. First, let's just focus on this thing. There are 2 yellows, there are 2 reds, there are 3 blues, there is this orange, purple and green. So exactly 1 yellow book. That has to be 1. So this will always be 2C1, that is for sure, and that is what you're seeing it over here. Now, when we are talking about red, this is at least 1 red, so it could be 1 red, it could be 2 red. It could be 1 red, it could be 2 red. And at most 1 blue, so it could be 0 blue, 1 blue, 0 blue, 1 blue. Now look at the combination that I've done. So this 1 is fixed. This is 1 0 1 1. This is 2 0 2 1. All the combinations are completed. 1 plus 1 is 2. The remaining 2 out of these. 1 plus 1 plus 1 is 3. The remaining 1 out of this. 1 plus 2 is 3. Remaining 1 out of this. 1 plus 2 plus 1 is 4. Remaining 0 out of this. So basically, when I show you the working before that, this is 2C1, 2C1, 3C0, 3C2. And this is 2C1, 2C1, 3C1, 2C1. And this is 2C1, 2C2, 3C0, 3C1. This is 2C1, this is 2C2, this is 3C1, this is 3C0. Just look at the working. Whatever you are thinking, write it down. First, second, third, fourth, 12, 36, 6, 6. It adds up to 60. That is 60. That is the number of ways. So that completes this paper. And let me go back over here and write a few other things down. So now what I feel is that this thing is there. And in permutation combination, focus a bit more on number formation. They haven't asked number formation since a long time. And then there were questions about like sitting on a table or sitting in a bus type of question. Also have a good look at that. So these are a few things that are in my mind at the moment. So focus on these, and the rest of the thing are the same simple thing as before. That is stem plot and box plot and these things. There is nothing special about these, or maybe histogram. Yes, coding, some kind of coding could be asked. So focus on the coding also. Basically, you have to focus on everything. These are some of the things that are just coming to my mind. So letting you know right away. Stay tuned for more content, which is tonight for this particular year exam. And that would be the live session on YouTube. Take care, everyone. Allah Hafiz.